Hello, everybody. So, welcome to the session, Flexible Gas Engines. And thank you very much also for taking a seat. If you wish to follow, we have three interesting speakers. And I would like to start with introducing Dr. Lars Eigenmann. He is CEO of Kraftwerke Mainz-Wiesbaden. That's a 1,000 megawatt set of power plants consisting of waste to energy, combined cycle gas engines, wind, photovoltaic, so the whole range. And he will tell you more about how this system is working and is contributing to the German power market.
Thank you, Mr. Hart, for the introduction. Yeah. I will start shortly. I would like to thank you and show some things about the energy transition in Germany. The former speaker said about the European exchange. And as you might know, we have an economic impact after our coal phase out now in the 2020s. And looking at the conventional power generation, we'll see that in the next few years, until 2025, we will have a drop of conventional power from about roughly 90 gigawatts per year, gigawatts to 60 gigawatts, and going up to the peak load in Germany is about 80 gigawatts, and rising up into the mid of 20th and the end of 30s, about 90 gigawatts because of the sector coupling, maybe the increase of flexible heat and heat pumps, and also the heat e-mobility. So we have to catch up this gap from 60 gigawatts load to the 80 gigawatts at the peak load per year. And if you are looking at the electricity generation, you see here on the slides the year 2011, 2018, and the future studies for 2030. We have also here in the electricity generation a drop about 40%. So only gas, hard coal, and lignite coal and nuclear, which are secured power, will go out, or nuclear, lignite, and hard coal will go out of the market in the recent times. As you know, we have these times a so-called a law in Germany, which is a so-called bidding process for the hard coal power plants for the next, I think, 2 or 5 years, where 4 gigawatts per year will go out of the market. And the hard coal power plant, the lignite coal power plants will end. The last end will be, or the last phase out will be in 2035 or 2038. So there's a secured power going out of the market, out of the energy market, and the aim is to fill this gap of secured power by wind, biomass, photovoltaics. And having in mind, wind and photovoltaic is not secured power, but we want to have, or what we want to install in the market from 2018 to 2030, more than double of wind and photovoltaics. So we have at the end more than 200 gigawatts in the electricity connected to the electricity net, and this is more than double of the peak load we have in the 2030s, about 90 gigawatts. So you can imagine what challenge we have, and therefore I show you some example which show you this challenge in the former times. We have here 2017 year, some days in from the 11th to the 15th January, where you see here on above the so-called the supply, or the load we want to have, or of about 80 gigawatts. This is the max here, and you see also the big ramps in several hours, where we have a change in fluctuation in our supply, about 20 gigawatts in several hours. And in the windy and cold days in January 2017, a few days we have the load, 55% of renewable energies can supply our load we want to have. But 10 days after, in the mid of or the end of January, there's only 10% of renewable energies when fulfill the supply. And you can imagine if you double or triple the renewable energies without any wind and without any sun, you can double and triple it. We have, at the end, no electricity out of this. So this is the challenge we have. And as mentioned before, we have the solution should be or must be to get to put this excess energy, the excess electricity, into storage forms. The first thing it will be the short-term storage, maybe compensating by batteries or pump storage, and the long-term storage it takes for days and more than weeks or months. We have to take over in the long-term storage for the cold and no wind phase, and this could be, as is mentioned before, gas turbines or power to X or power to gas things, which would be at the end the insurance for the multiple or weekly storage. To imagine what is the storage today in Germany, if you put all the electricity storage, what is in the household, the batteries, and also the old the old pump storage we have in Germany, we have only 34 minutes for storing a normal cold winter day. If you put 4 million cars into this system, you get compensated about three and a half hours in a cold winter day. And the only infrastructure we have in Germany is the gas net with its caverns, which are possible to store energy about 3 months. So why should we not take these infrastructure for the next decades, store some biofuels and with power to X, and take some gas turbines or gas engines to ensure the power supply in Germany. Looking on the market, what is happening on the market, you see this time is an intraday auction. The intraday auction says on the red curve here, the intraday auction prices for this is April 2019. You see there are some only a few hours of economical use for gas turbines or engines, which are over the marginal price of each technology. And going further to 2030, this reinforced, the prices are more reinforced by the development of renewable energy, and the prices are dropping in the midday dramatically down. So there is no economical use then of gas turbines or engines. And for the future times, therefore, we need reliable startup reliability, startup time, and flexibility in our new technologies. And this could only be fulfilled, in our perspective, only fulfilled by gas engines, which have no startup costs, are highly flexible, have a high flexibility, a startup time which is very fast, and also a startup reliability. To show you the game, I've put here some startup ramps of different kinds of technology. For example, coal power plants, open gas turbine cycles, and so on. And you see the additional performance gain with a gas engine is very high. So with a startup ramp in maximum 2 minutes to full power, with no additional startup costs and unlimited starts too. As you see, sorry for that. As we see, we have in the future time more than 200 starts per year for such a machine, and this could only be done by our perspective with gas engines, because open gas turbines are too expensive in the maintenance. Switching to our portfolio, we have built up now with versatility together a so-called CHP gas engine with a storage. And this is fit in our portfolio with a CCGT gas turbine with 420 megawatts and a waste-to-energy power plant, and serving our customers as district heat and also as steam. And Therefore, we have built up this 100 million euro new combined heat and power plant with modular heat storage systems, because heat storage is needed with a ramp-up time of 2 minimum minutes. We have after 5 minutes the heat, and you have to store it with in a so-called heat storage. The gas engines is 10 times 10 megawatts with an efficiency electric efficiency more than 46%, maybe more. We look at Wärtsilä. And the fuel conversion efficiency about 85%. The heat storage has a 750 megawatt hours storage capacity with a temperature level of around 120 degrees and an output load fitting with the motors to 100 megawatt input and output load. How is it looking like? This is a picture made days before. You see it's ready. It's at the end not an engine, it's a whole power plant. On the top or on the roof you see the ready areas if we are not running the machines in CHP mode. So we can run it in electricity mode or in CHP mode. And it's going to have his COD in the first quarter of 2020. And we hope so. And then running the machines with superpower. Looking inside a cell, how is it arranged inside? It's a cell has 2 motors. This is to get the best comparison between having a good maintenance concept at the end and with the economical value of the gas motors. And therefore we put only 2 motors in one cell. And this will be the next time and the next future. Yeah. And for future, I would say today we have normally the production, then the transportation by the TSO and DSO and the consumption. But for the future, our motors will provide for renewable energy a smart integration as a service in the future, because they are highly flexible, have a low startup cost, a reliable startup cost. So if the renewable energies are not here, we can start up in 2 minutes and fix or compensate the amount which the renewables are not in the market. But we also need the so-called the aggregators and automated sector coupling with all these things of the conventional power plant, smart grid and renewable energies in the future. Thank you very much, and that was it. Yeah.